Okay, in this video, we're going to talk about similarity and transformations. A couple of videos ago, we talked about two shapes being congruent, and we said that two figures were congruent if you could map one onto the other using translations, rotations, or reflections, and that meant that they were the same size and shape. But now we're going to talk about including our dilations. And if you can map one shape onto another using dilations, translations, rotations, or reflections, this means that they are the same shape but not the same size. We call these shapes similar. So if you can map one onto the other using all of our other transformations now, including dilations, we call them similar. So at the bottom here, I have kind of a summary of these two concepts when it comes to shapes. Congruent means that they're the same shape and the same size. However, similar means that they're the same shape but different sizes. So if we can map one onto the other now using dilations, we would say that the two shapes are similar to one another. So determine if these two triangles are similar by performing transformations. So what we're going to look at is, can we make these the exact same size? So we're going to try to find a scale factor that will translate one into the other, or transform one into the other likely. So I'm going to include some missing side lengths here. So I've got DF is 3 units long and DE is 4 units long. GI is 6 units long and GH is 8 units long. So looking for a scale factor, is there a single scale factor that will produce the same side lengths if I were to perform a dilation on one of these? So I'm going to see if I can dilate the smaller one and enlarge it to the larger one, and I'll see that these corresponding sides here, if I would have to go from a side length of 5 to a side length of 10, that would require a scale factor of 2. Now, is that scale factor going to work for the other sides? 4 would then map to a size of 8, and 3 would map to a side length of 6. So I can use a scale factor of 2 to produce the same side lengths on the larger triangle, and then I could perform probably a slide or a translation to map triangle DEF to triangle GHI. So I would say yes, these are similar because I can perform a dilation with a scale factor of 2 and a translation to map triangle DEF onto triangle GHI. So these would be similar triangles. What about these two triangles? Well, again, I'm given two side lengths here, the 5.8 and the 11.6 units long. So again, if I was going to use a scale factor to try to dilate the smaller one to the larger one, I would have to use a scale factor of 2 again. So will that scale factor work for the other sides? Well, this side here, ST, is 3 units long, and the bottom UT is 5 units long. And then on the green triangle, QR is 10 units long and PQ is 6 units long. So again, you can see I can map these side lengths to the larger ones by using a scale factor of 2. So what other transformation would I have to use? Once I dilate this using a scale factor of 2, they would be pointing opposite directions. So I would just have to flip triangle STU over to map it onto PQR so that they would line up exactly. So then I would use a reflection. I would reflect triangle STU horizontally onto triangle PQR. So I would use a dilation using a scale factor of 2 and a reflection to map the smaller triangle onto the larger one. So these two shapes would be similar because I can map one onto the other using my transformations. And lastly, we've got a couple of rectangles here, ABCD and EFGH. Can I map one onto the other? Well, again, I'm going to look for my dilations here. This is a 2 by 4 rectangle, and this one is a 3 by 5 rectangle. So to map the shorter length to the corresponding shorter length, I would have to use a scale factor of 1.5. And if I try to use 1.5 to map this other side onto the 5-unit side, I would not get 5. I would get 6. So I cannot use the same scale factor for both sides to map one onto the other. So these are not similar because there's no scale factor I can use to map one shape onto the other. So these would not be considered similar shapes. So how can you tell if two shapes are similar? If you can map one onto the other using a series of any of the transformations that we have talked about, whether it's a translation, rotation, reflection, or dilation.